basically, while we're graphing these, they're going to take the same form that they did before when we were doing vertex form for parabolas. Well, we have vertex form for square roots and cube roots. We multiply by some stuff, add or subtract to go left or right, add or subtract to go up and down. So that'll change the center of our graph. For the cube root ones, the center is here, and for the square root ones, the center is on the end. Right? It just depends which one we're doing. And remember, 1/2 means square root, 1/3 means cube root. It's all the same. Okay, so for our first example, we're actually going to do one that I haven't done before, and we'll record it. Just let me double check. Okay, so we'll start with a cube root one. Cube root of -2x, and then we're going to add 1 on the end. Okay, so this is going to move it up. This is going to stretch or shrink it and flip it because it's got a negative, and we're doing a cube root function, so it's going to look kind of like this. Okay, so we're going to do all our steps, except I'm not going to write them out. I'm not going to write like step 1 is plot the table. I'm just going to make the table. So we're still going to do all those steps. I'm just not writing out what each step is. Now, for cube root, we said, okay, we'll start at 0 in the middle, and we're going to go minus 2 in each direction and plus 2 in each direction. And, sorry, here probably. This has not changed because we're not adding or subtracting inside this radical. We'll do another one in a minute where it does move because we're adding or subtracting in here, but this one we're not. Okay. We're gonna need a calculator because we're doing the cube root of -2 times something. And so the only one of these that's gonna come out easily by doing hand math is the 0. If I put 0 in here and I add 1, we just get 1. The rest of these all are gonna take a calculator. So what I'm gonna do is I'm just gonna type this into Desmos and change this x until I have all 4 numbers. So let me find Desmos. Here we go. So I'm going to get rid of this y equals, but I'm still going to use the cube root, and it's -2 times something plus 1 on the outside. Make sure you put the plus 1 on the outside, not on the inside. Okay, and so now I'm just going to type in all the numbers. So -2, whoa, whoops, -2. So my number there is going to be 2.58. And then -1 is 2.25. I might be going a little quickly, but I'm going to put these numbers in the table and show you the table, so it should be fine. And then -0.25. And then I think -0.58. Yeah, 0.58. Okay. So my table ends up looking like this. And I used a calculator to find almost all those values, which is totally fine. So 2.5, 2.25, 1, -0.25, and -0.58. So this is kind of symmetrical. You can see the numbers on both sides. It's been shifted up one, so the number in front here is not the same across the board. But when we graph it, it'll look correct. So 0, 1, start at the middle. It's about my scale that I'm using. And then we would do back 1 up 2.25. So there, and then back 2 and up 2.58, so about and then 1 comma negative 0.25 and 2 comma negative 0.58. So our graph looks like this. Not perfect, not to scale, but about like that. Okay, so we use the table, and then for cubic functions, we just say, oh, the domain is all reals, and their range is all reals. Because we could plug in any x value and any y value. Whoa. Okay, let's do another one where instead of outside adding subtracting, we're going to add inside here because it's going to change how we do this, but also it's going to, this shifted this curve up. It also got reflected because there's a negative here, but this is going to shift it left and right. And so we're going to do the cube root of, or 2 times the cube root of x plus 3. Okay, now this might look confusing, but it's 2 times the cube root. X plus 3 is inside. So I'm going to make my table. Should probably be using a couple of colors here. Now the reason we're doing this example is because now I'm not going to make my center number 0. What we want is a center number that changes this x plus 3 to equal 0, which means x is going to be negative 3. To turn this into 0, you put in a negative 3 in here. That's where the vertex is, basically. We've done that before. So what I'm going to do is I'm going to put the negative 3 in the middle, and then we'll go minus and plus. And so yes, we're putting in different numbers, but this is still going to be the center of my curve, and we'll go left and right from there. All right, so we don't always want to put 0 in the middle. It depends on what this is. So if I put negative 3 in here, still get 0 because we're multiplying here. So turns into 0, 2 times 0, 0. Negative 4, if I put a negative 4 in here, I get negative 1. This turns into negative 1, so this is going to be negative 2. And this is going to be 2. And then for these, we need the calculator. Okay, and so that's going to give me, it's the wrong window, 2 times negative 2, negative 2.51, and then this is going to be 2.51 positive. Yeah. So I did that with the calculator off screen. Okay, so then we just graph those points. And actually, before I even graph it, we can know the domain and range. Domain, because it's cubic, domain is all reals, and the range is all reals. I haven't even put anything on the paper here. And I already know because this, I can put any number into here, and because it's cubic, we can have negatives inside. And we'll get out negative numbers and positive numbers. So when we're graphing, we got negative 3, comma 0, negative 4, comma negative 2, and those, and negative 2, comma positive 2, and then negative 1, comma 2.5, which is like here, and negative 5, comma 2.5. So it's going to do this kind of thing. And then we're done. Ow. Okay, I'm going to do 2 more examples. Any questions on those so far? I haven't seen any notifications, so see any questions? I don't know if I'm going, hopefully I'm not going too fast. We're going to do 2 more where we do square roots. I'm going to use the same numbers though, these same numbers. So example 2 is going to be the square root of negative x plus a 1 on the outside. And example 3 here, or I mean example 4 is going to be 2 square root x plus 3 inside. Back. All right. So same deal. Make a table, plot the graph, talk about domain and range. These, because they're square roots, are actually going to have domain and range. That is not all reals. So for this one, we haven't moved left or right. There's nothing happening inside the radical. So we can still start at 0. It's not going to simplify super easily. Oh, actually, I made a mistake, which is easily fixed. Look, if I put a 1 in here and I get the square root of negative 2, I'm going to get a negative number. We can't have the square root of negative. That means all my inputs have to be negative to multiply by this. So these actually have to go the other way. This is a reflection. This has been flipped over the x-axis, the y-axis. And so it's gonna make a curve that looks like this, going that way. Okay, so we're gonna put in we still start at 0, but we're gonna put in a bunch of negatives. So when we multiply, this turns into a positive. So right, if I put in a negative 1 there, it's gonna be the square root of 2 plus a 1. Square root of 4 plus 1. So this one's actually 3 here. So this is 1, because 0 and then 1, 1. Need a calculator. Makes the square root of 4. And then need a calculator for both of those. Okay, so let's type those in to our calculator. We get, this is going to be a square root. We're not multiplying out here. We are adding out here. This is negative, and then our parentheses. So we're going to put in a negative 1. I get 2.41. Going to put in a negative 3. I get 3.44. Put in a negative 4, and I get 3.8. You'll notice 82, sorry. I did that kind of quickly, but here's the table. You'll notice the distance between these points gets progressively smaller. All right, so when we're graphing them, the jump from 0 to negative 1 is actually larger than the other jumps between the distance between the points vertically. So we start at 0, 1. It's right here. And then we're going to go this way. Negative 1, and that'll be 2, 2, or negative 1, 2.4. Negative 2, 3. Negative 3, 3.4. Negative 4, 3.8. So it goes like this. That way. Give or take a little bit. And then our domain and range are directly connected to this point and which direction the graph goes. So the domain is x. Since we're only going left, it's smaller than or equal to 0, this point right here. Our range is the y values, and they're still all positive, but it starts at 1. And so that's our domain and range. So we're going left, x is smaller than 0, and y is bigger than 1, so we're going up. Okay. We good on that? Maybe? The big things I want you to be able to do are look at a graph. I'm using my mouse to point at things. You can't see that. Look at a graph and determine the domain and range. This is just plugging numbers in, right? And I'm picking specific numbers that are easy, but you can pick all the numbers and figure out if they work. You can also just plug this into Desmos and it'll look right? And you can use that to fill out your table. All right, one more. You'll notice we went up 1, so it moved the graph up 1. We had a negative inside, it flipped it over this way. Okay, this one's not going to get flipped over, but it is going to move to the left because it's plus 3 inside. So our table we're not starting at 0 again. So if I put in 0 here, we've missed some numbers. We start where x plus 3 equals 0. Because that turns this into 0. So we start at negative 3, and then we're going to go up. So negative 3, negative 2, negative 1, 0, 1. Counting up the number line, adding 1 each time. So this is going to give me a 0. Plug this in, we get 1, we get a 2. 2 times 1. Plug this in, we get 2 root 2, 2 root 3, and then this one will be 4. So you could plug those into your calculator and figure them out, but you don't actually need them because you have the other points. So when we do our coordinate plane, start at negative 3 comma 0, 2, 3. We do negative 2 comma 2, and we do 1 comma 4. 1, 2, 3, 4. And so we know that the curve is going to go through all of those. And so we don't really need these. They're going to be on this curve somewhere. And then the domain, and then the range. I think I'm going a little fast. So we could calculate these, right? We're going to get decimals, but they're going to be in between this point and this point. They're not going to be like way out here or way down here. They're going to be on this curve. So we can just draw the curve between the points we got. Probably not perfect. Probably plugging decimals would give us a more accurate curve, but it's close enough for a sketch. Can't really do that with all of these, right? We don't have a number in this. We need to calculate these decimals. This, though, we have another point to base our range on, and so we can actually get a good guess. So domain is x, range is y. Here, it's going to be x is bigger than this point. We're going to the right of negative 3. It's all the values this way. And here, the range is going to be y bigger than 0. It's all the points up here. Okay, so we got like 5 minutes left. We'll finish a little bit early, I think. There are office hours today. I'm going to upload this and the other ones.